Okay, good morning, my dear students. You're on to Mamu with Jarvis, and it's a YouTube channel dedicated to solving problems in mathematics. Okay, so we'll still go back to look at grade 10 work today. And on today's segment, we'll be looking at something called algebra. We've started. And the topic for consideration today is called standard form and indices. We've also started that too. And in our last class, we tried to look at some examples and some applications of standard form in unique setups. So we'll go right into the class. But don't forget, our textbook of reference is the Essential Mathematics for SS1, which is called grade 10. Right? So we'll go straight to work right now. We start off this morning by looking at exercise, continue with exercise 4.1 of our textbook. And then we've done question 1, question 2, question 3. And we were on question 4. For want of doubt, I want us to take those questions again, right? Because I discovered something rather tricky in the other class. Okay, so we look at question 1. Question 4 of exercise 4.1. And the first question there says we should solve and express in standard form 5.6 times 10 raised to the power of 6 plus 4.5 times 10 raised to the power of 5 plus, or rather minus 5 times 10 raised to the power of 4. So how do you go about this? We are going to bend the rule a little on what we know standard form to be. But get this, in solving this, your first objective is to try to get all the numbers to a particular power. Now, I will take all the powers to power of 6, and then I'll try to make others to that. So 5.6 times 10 raised to the power of 6 will still be 5.6 times 10 raised to the power of 6. Now, 4.5 times 10 raised to the power of 5 will be, I want to make this to the power of 6. It means if I increase this, I will reduce this. Increasing this power will cause a corresponding decrease in this figure. Remember, we said that when you increase the power, what you're trying to do, you're trying to make the number small. When you reduce the power, you're trying to make the number big. All right. So that is understood. This becomes what? 0.45. Okay. Now we have 5 times 10 to the power of what? 5. 10 to the power of 4. What does that give you? That will give you, my first consideration is to make this to the power of 6. So what do I do? What have I done to cause this? I have increased this power by 2, and by so doing, I need to reduce this. Remember, we said that for every whole number, the decimal point exists after the unit. So I'll go back 1, 2, and by concept, I'll put 0 here and then put 0 points. All right, so it becomes 0.05. All right, now remember that our task is to add these two and then subtract from this. All right, so that gives me what? 5.6 minus what? 0.45. Oh, sorry, plus 0.45. Whatever I get times 10 raised to the power of 6. And this will give me 6.05 times 10 raised to the power of what? 6. And then I'll bring this one in, minus 0.05 times 10 to the power of 6. And that will give me what? 0.6, which invariably becomes what? 6 times 10 raised to the power of what? 6. And that solves that particular question. So let's continue. Okay, so we go to second question. It says 3 times 10 raised to the power of 8 minus 5.1 times 10 raised to the power of 6 in brackets plus 8.3 times 10 raised to the power of 7 in brackets. So your first task. Now, if you notice, this is subtraction, this is addition. And by the concept of board maths, although sometimes it wouldn't really matter, board math tells about the steps you need to take while solving problem. It might not really matter. But by concept of board maths, we're expected to do addition first. So this one that no sign is written in front and this one that is plus should be done first before you now subtract. And I think it makes common sense. I try to put together the money I have. At least in this scenario, I try to put together the money I have. If I'm talking about coming to pay somebody, I must know what I have if I now pay somebody, so that I won't write a check that will bounce. Okay, so this will now be what? 3 times 10 raised to the power of 8. Then I'll bring this one, 8.3 times 10 raised to the power of 7. Now, my reference will be to the power of 8, because that's the highest power I can see. This will now be 3 times 10 raised to the power of what? 8. Now, I'm going to try to do this. I will start by taking care of 10 raised to the power of 8 first. How did I do that? I added 1 to 7. And the corresponding effect is that it will reduce or move the decimal place of this one to the back. So what you're going to have is that the decimal will come back like this. And then it will now be what? 0.87. So having done that, I will now do what? Add it up. So I'm going to have something like this. I'm going to rule that line of meaning that I've taken care of that observation I want. Then I'll come to this line. It will be 3.00 because I have 2 decimal places here. Plus what? 0.87. I put my plus sign there. And then I'll add it up. This will give me 3.87. Now just put times 10 to the power of 8. And that will be what? Times 10 to the power of what? 8. Now you discover that my approach and my solving technique is quite different, because I try to ensure that you write, you communicate properly, and as much as possible, you're not writing too much. I noticed that that's a trend in modern maths. We don't write too much, but we try to use very, very short statements to pass our points to our examiners or to our teachers. Now, we've done that. Now, the next thing we need to do is to try to handle this one. So this will be 5.1 times 10 raised to the power of what? 6. What does that mean? I'll first of all try to make this to the power of 8, because that's the reference power I'm using. Then look at this. What do I need to do? I need to add 2 to 6 to give me what? 8. Is that not? So if that happens, the corresponding effect will that it will make this go back 1, 2. So this is where my decimal point will now come to in its new position. So what I'm going to have will be 0.051. Are you with me? Good. So if that is done, I will now fuse this to this. So it will now become what? I wrote another line to tell myself that I'm done with that operation. So I'll have a 3 point, just more like the way computers behave these days. You know, I'm done with that process, push it off, pick a new idea. So this will be 3.870 because I have 3 digits here, minus 0.051 times 10 to the power of 8. You don't need to be writing 10 to the power of 8 every, no, just good. And this will become what? 0 minus 1. It's not possible. So I need to do what? I need to take from my 7 Naira account and put it here. And I'll get what? 9 here. And I'll be left with what here? 6. 6 minus 5 is 1. 8 minus 0 is 8.3. So that'll be 3.817 times 10 to the power of 8. So just by way of cosmetic finish, it will be 3.819, times 10 to the power of what? 8. So that's the answer or the solution process to question 4B. I'll give us some time to take care of that. All right. This is now what if you observe closely, we had tried to use standard form in the manner of where we are adding. So when we are now dividing, what happens? Or rather, when we are now multiplying and dividing, what happens? In the sketch before us here, we are required to do what? To multiply this times this. So how does this work? This will be equal to, once you've seen the multiplication sign here, it will be 6.3 times 10 raised to the power of 6 times 4.3 times 10 raised to the power of 7. The reason I've done this is to tell you that the brackets here for this is not affected. The multiplication sign does not affect what this content would be. Now, this will now be what? Watch, this will be what? 6.3 times 4.3 times 10 raised to the power of 6 times 10 raised to the power of minus or negative 7. So we'll try to multiply these two. We'll get an answer. And then in dealing with this, now this is where we will come into this topic very soon, and then I'll begin to explain certain things for you. Now, what does this mean? What is the interpretation of this? Now, the interpretation of this part is this: 10 raised to the power of 6 over 10 raised to the power of what? 7. Now, if you look at this, this is 6, this is 7, and this would mean this: 2, 3, 4, 5, and 6. This will mean 1, 2, 3, 4, 5, 6, 7. So let's cancel them out now. 2, 3, 4, 5, 6. So we're left with what? 1 over 10. So let's multiply this. What do you get here? The general rule in multiplying the decimal says that when you multiply the numbers as though you were multiplying whole numbers, and then account for the number of decimal places. So this would what? Give me 9. 3 times 3 is 9. 3 times 6 is 18. 4 times 2, 4 times 3 rather is 12, a carry of 1. To what? 6 times 4 is 24 plus 1, 25. And that should give me 9, 0, a carry of 1 to this part, which make it what? 7. This is plus. Always remember to do that. Is plus. That will be 7, and that will be 2. So what I'm going to have invariably will be something like this: 27.2 decimal places accounted for, 0.09 times 10 times what? 1 over 10. Now, 1 over 10 would mean this, I can write to mean 27.09 divided by 10. Now, divided by 10 means move the decimal indicator one step back. When you divide by 10, you are moving the decimal indicator backwards. When you divide by 10, you're moving the decimal indicator back. When you multiply by 10, you're moving the decimal indicator to the front. So with this answer becomes what? 2.709. That's what my final answer will be. So it will be times 10 raised to the power of 0. I will explain some of these things much better later, but for now, let's just stick to this simple iteration of the answer. Okay. Okay, we'll go to question D now, and it says 4.5 times 10 to the power of 5 times 4.2 times 10 to the power of what? Negative 3 divided by 8 times 10 raised to the power of negative 4. All right. Now, the first thing you need to do is to put this in perspective. This times this divided by this will now be 4.5 times 10 raised to the power of 5 times 4.2 times 10 raised to the power of negative 3. This is 4.2. I should put that well. This is 4.5. Divided by 8 times what? 10 raised to the power of what? Negative 4. Right? So how do we go about doing this? The first thing I will advise is for you to take care of the top. So I'll rearrange this to be 4.5 times 4.2 times 10 raised to the power of 5 times 10 raised to the power of negative what? 3 divided by 8 times 10 raised to the power of negative what? 4. Right? So we're just trying to use very simple approach. By the time we get into the laws of indices, you discover that the essence of the grade 10 class is to pick up laws that can help you make your solution process faster than you had been solving previously. All right. Now, what's going to happen here? I'll multiply these two and divide it by this. So I will take it gradually. I will have 4.5 times 4.2, and that will give me 0, carry of 1, 4 times 2, 8 plus 1, 9, and then I'm going to have 4 times 5, which will give me what? 20. I'll put down 0 and carry of 1, carry of 2 rather. 4 times 4 will give me what? 16. 16 plus 2 will give me what? 18. So this answer will be 1890. Taking into consideration that I have 2 decimal places accounted for to be 1, 2. So this will be what? 18.9 times. This means 10 raised to the power of 5. This minus means what? Divided by 10 raised to the power of what? 3 all over 8 times. Give me gradually. By the time we come to the lot of 8 divided by 8, will give me what? This will give me 2 point. That's 16. That will be 29. That will give me 3. I put in another invisible 0 here. I'll be left with 5. That will give me 6. Put another 0 there. That will give me 2. Put another 0 here. That will give me 4. So that will be 3.625 times. Now this is to the power of 5. Means divided by 10 to the power of 3. Means cancel 3 tens. And that will give me 10 raised to the power of what? 10 raised to the power of 2 times 10 raised to the power of 4. The question you ask me now is that, Uncle, how are we having 10 raised to the power of 4? Look at this. Let me interpret this aspect now. So let me interpret this aspect. So look at this carefully. 10 raised to the power of negative 4 will mean 1 over 10 raised to the power of what? 4. Remember that it is something divided by 1 over 10 raised to the power of negative 10 raised to the power of 4. So what happens is that this number itself is a numerator. I think because of our classes, we had established that this number in itself is a numerator. But no problem. If you don't get the idea right, when we come into laws of indices, you will see them clearly. And this answer becomes what? 2.3625 times 10 raised to the power of what? 6. Okay. All right, so let's go to the next question. The question says 4.14 times 10 to the power of 4 minus 0.00014 times 10 raised to the power of what? 7. Now your first task is to try to make this one to resemble the standard form of this number. I mean, to resemble this in terms of the power of this. So what I have here is 4.14 to the power of what? Times 10 to the power of 4, taken care of. Now, this will still be this. I don't have a problem with that. Now, let's look at this. This is where there is a challenge. Now, how does this work? Remember we said that when we reduce the power here, invariably we're increasing this. When we reduce, we're what? Increasing this. So if we reduce this, we're increasing this. So if you watch this carefully, I want to make this. If you look at this, I have 14 here. So I want to move. How many decimal places will take me to a decimal of 0.14? 1, 2, 3. So I will remove 3 from here. 7 minus 3 becomes 4. And then this one becomes what? 0.14. So what does that give me? I'll roll up that. I'm through with that arrangement. So it will be 4.14 what? Minus what? 0.14 times 10 to the power of what? 4. This will give me what? 4.00 times 10 to the power of what? 4, which means 4 times 10 raised to the power of 4. I'll close that one out. But remember that what they want you to find is the square root. So the square root of 4 times 10 raised to the power of 4 will now be what? Let's use our old method. I will use our old method. This will mean 4 times what? 10,000. I know this method, you can easily relate with this method because 10 to the power of 4 means multiply 10 how many times? 4 times. So this will give me what? 40,000. So what's the square root of 40,000? It is what? 200. Square root means break it into two numbers that such that when we multiply these two numbers, we are able to get this original one. So this is a perfect square. So we need two of the same number that must be multiplied to get the answer. So this will give me what? 200 as our answer. But that's not what we're told to do. We're told to leave it in standard form. So we will write this in standard form, which becomes 2 times 10 raised to the power of what? 2. 2 decimal places back times 10 raised to the power of what? 2. And that will take care of that problem. Okay? Now in question 5, it says evaluate the following. Evaluate the following giving your answers in standard form give your answers in standard form, correct, giving your answer in standard form, correct to Roman figure 1, 2 decimal place, and Roman figure 2, 2 significant figures. DP means decimal place and decimal places, and then SF would mean significant figure or figures. All right, so we will then go ahead to handle that. There are 3 questions there. A says 8.01 times 10 raised to the power of 8 times 6.51 times 10 raised to the power of 5. All right. So the first thing you want to do here, is to rewrite this. This becomes what? I always advise my students, take off the decimal points, take off the brackets. Once you're multiplying, the brackets are not affected. So it will be what? The next thing, rearrange them. See, you must do these things patiently. Why you may not do this in an exam hall, while practicing, you need to do them so that your mind can help you know if you're going to jump a process, understand why that process could be avoided. Now look at this. This one means 10 to the power of 8 times 10 to the power of what? 5. Now, so this power, when you multiply numbers, what you are doing to their powers that you are adding them. So this will be what? I'm going to multiply these two, and this is what I'm going to have. Are you seeing that? Times 10 to the power of what? 13. You might want to ask questions like, how's that one coming? No problem. Like I told us, we're coming to laws of indices. And when we come to the laws of indices, you'll get to understand all of this. You actually have done this in your grade 8. But I want to assume that perhaps you may have forgotten. Maybe it's a little hazy in your mind. So when we come to indices, you get to appreciate the work we're doing now. But as a general rule, if the bases are the same, their indices, you can add up their indices as long as you're multiplying. But if you're dividing bases, what you do to their indices is that you do what? You subtract them. All right, we'll get to that. So let's go. This will give me 801. How? 108. Now 5 into this will give me 5 times that will give me 5. Times 0 will give me 0. Times 8 will give me what? 40. Remember, we are adding. Now, 6 times 6. 6 times 1 is 6. Times 0 is 0. Times 8 is what? 48. And when you add all of this together, you have 1, you have 5, you have 4, a carry of 1. Added to these zeros, you have 2, a carry of 1. That becomes what? 5. Now, how many decimal places are you playing with? You're playing with 1, 2, 3, 4. So it will be 1, 2, 3, 4. So my answer becomes what? 52.1451 times 10 raised to the power of 13. But that's not the answer. Because remember that we are to express our answer in what? Standard form. Standard form is the expression of a unit decimal times the number of movements. Now, because I have reduced here, I will increase here. So this becomes to the power of what? 14. Okay? All right, I'll just clean this part over or clean it off. And what you're going to see will be something like this. Now, this is the answer we have gotten. But remember that you are told to look for the answer 1 to 2 decimal places. So to 2 decimal places means a decimal place is a place just after the decimal point. A decimal place is a digit just after the decimal point. I'll come again. A decimal place is a digit just after the decimal. So if they say to 2 decimal places, it means take into consideration the first and the second digit. Now, we look at the digit of interest and the digit causing the approximation. The digit causing the approximation is not up to 5, so we can neglect all of this, and the answer becomes 5.21 times 10 raised to the power of what? 14. That is to 2 dp. Now, we have yet another consideration where we are now told to talk about two significant figures. How does this work? For two significant figures, we start counting from the non-zero digits. For two significant figures, we start counting for the non-zero digit that is most significant. And in this setup, 5 is the most significant. So 2 decimal will mean consider this digit and consider the next digit. And then we look at, this is the digit of consideration and this is the digit causing the approximation. You'll discover that for approximation to occur, it must be 5 and above. So we don't have a need of all of this. So it becomes what? 5.2 times 10 raised to the power of what? 14. To two significant figures. All right. All right, the next problem. This would mean this interpretation of this divided by this. So you have 9.06 times 10 raised to the power of -9 divided by 5 times 10 raised to the power of -6. So we will need to take care of this. And that will give me, by dividing this, I'm going to get 1.81812. You may want to try that out on your own. And this will be 1.812. This divided by this times. This is what? 10 raised to the power of -9 divided by 10 raised to the power of -6. Now, this will now mean 1.812 times 10 raised to the power of 6 over 10 raised to the power of 9. Now, somebody is asking me, what has just happened? Take note of this. 10 raised to the power of -6 will mean 10 raised to the power of -9 is equal to what? 1 over 10 raised to the power of what? 9. And 10 raised to the power of -6 will mean 1 over 10 raised to the power of 6. So if you now say this divided by this, you're implying that this will be what? 1 over 10 raised to the power of 9 divided by 1 over 10 raised to the power of what? 6. And from elementary mathematics, you know that this will be 10 raised to the power of 6 over this. Now, when you divide, you discover here that this will be 1.812 times, this is 10 to the power of 6 or 10 index 6. This is 9. You discover that this is less than this. 6 minus 9 will mean that there's a deficiency of what? 3. We need 3 more to be able to get to 9. So that will mean that this will be 10 raised to the power of -3. That is 6 minus 9. The bases are the same. And once you're dividing numbers that are the same, what you are doing to their indices that you are doing what? You're subtracting. So it is numerator minus what? Denominator. Now, this -3 means that I am duty bound to move this by 3 places to the left. But that's not the objective, because what they want us to do is to, 1, express this as what? To 2 decimal places. So this will be 1.81. This is the digit of approximation. This is the digit causing the approximation. Digit of interest, digit causing the approximation. You discover that the digit causing the approximation is not up to 5. So we can neglect that value. And this will be what? Times 10 raised to the power of -3 to 2 decimal places. Now, what about two significant figures? What's happening there? You will discover that for significant figures, we start by taking the non-zero digits that is most significant. And in this setup, 1 is that digit. So we'll have 1 to 2 significant, 2 digits are of interest to us, and that'll be 1.8. We check the digit of approximation, digit of interest, and the digit causing the approximation. Now, this is the digit that should cause the approximation. you will discover that it's just 2. Sorry, it's 1 in this setup. Now, 1 is not up to 5, so it's not relevant to us. So that will be 1.8 times 10 raised to the power of -3 to 2 significant figures. And that would clear out the solution to those and to this particular problem. Okay?